So sorry, Caleb, forgot to turn it on for the first one. Okay, second one, we are solving. Actually, this was a good choice because this one causes a lot of issue when determining the common denominator. I've had a few people already asking me about this one. Since it's solving, you're allowed to do something that you aren't allowed to do when you're simplifying.
You can get rid of the bottom.
Thank you. Yes, you can get rid of the denominators completely. This is where you multiply through and you just cancel all the denominators out so that you have an equation you can solve with normal algebra. Okay, but the kicker to it is deciding the correct common denominator.
Yeah, you can just cross off the 3's.
No, I can't. Because that 3x is with a +1. So, my question to you is, when I'm determining the common denominator to multiply by, is it how many 3's are in that common denominator?
1 and 3.
Okay. That's a quantity, 3x plus 1, so you got to have a 3x plus 1. But the question is, do I also need a 3 and a 3x?
Just a 3.
I just need a 3, Colin's right, I need a 3 and you got to have an x because you got to cancel that x too. It's a lone x, it's not in a quantity. But you don't need both 3's is the kicker. And while we're at it, though, we were just talking about it, what are your excluded values while we're...
0 and negative 1/3.
Okay, how did Colin get 0 and negative 1/3? Yeah, what makes 3x equal 0? 0. 3x plus 1, if you solve it, subtract 1, divide by 3. So we can't have those two as answers. If we get done and one of those is an answer, we have to throw it out.
So why is it 3x?
Well, because this 3x plus 1 couldn't cancel that 3x. You can't cancel when there's plus signs. Yeah, if it's got something added, it's a quantity. You can only cancel whole quantity. You can't do individual terms. So therefore, you also have to have the plain 3x. So now, when you take it times the first one, basically ask yourself what cancels and what's going to be left. 3 cancels, so you have an x and a 3x plus 1 left, since there's just a 1 on top. All right, on the next one, what's going to cancel? What's going to be left?
3x.
This time the 3x will cancel, so you're going to have left. So you want me to just cancel the, okay, I would cancel the 3x, is that what you want me to do? So this time I would have the minus, the 5, and the 3x plus 1. You guys were good at these. These went well. Okay, so on the... Yeah, this one, when I times it, I'm going to lose the whole quantity, so I'm going to have a 3x left and the x plus 4. And now you're down to just an ordinary equation, no fractions. It's just regular algebra that we've become masters of. So I'm going to assume distributing here is not a big deal. Okay, what do I have to be careful of on the second one?
Negative.
Distribute the negative. So that's minus 15x and minus 5. And then when I distribute this one, I have 3x squared plus 12x. Okay, now that you have all that, oh, this is even going to, this is way too nice. What do you normally want to do here? Get them all on the same side, because you think, oh, I got squares, it's going to be quadratic, I'm going to have to factor it or formula it. But what's actually going to happen to these 3x squareds? They're going to cancel, yeah. This is going to be way too nice. Your 3x squareds are going to completely cancel. So I'm going to clean up the left side here. That's really negative 14x minus 5 equals 12x. That's all you got left. Positive 1, negative 15. Oh no, we have to solve for a lone x. Do we know how to do that?
Add the 14x.
Add the 14x, I'm with you. Will give me 26x equals negative 5. So x is going to equal a lovely negative 526. I don't think that was one of the excluded values. So we're good. We got a solution. If you really wanted to double check your answer, you could sub that back in the whole equation and see if it works, but that's an ugly number. We had 14 minds doing it. Surely we didn't mess it up.
I don't know, I'm gonna check it.
Okay, you're gonna check the answers.
Yeah. Okay, so how exactly do we know which one? You do that. Oh, that's right.
What makes every place you got an X on the bottom, you're asking yourself, where does 3X equal 0? Where does 3X plus 1 equal 0?
Okay.
You're just asking yourself, where does each one equal 0?
Put the one on the test like B.
Put the one on the test like B, okay.
I don't like this one.
This one was kind of mean. Yeah, B's probably nicer. Although I'm pretty sure B comes out with a quadratic equation at the end to solve. But I think you can solve those now.
What is the equation? Negative 3 plus or minus the square root of 4AC.
That's right, B squared minus 4AC. Then either learn it or put it on your card. Okay, can I go talk conics now?
Sure. All those shapes they do cones.
Remember the cone? Our friend the cone? Our friend the cone.
Cone head.
If you slice the cone straight across, you get a what shape?
Circle.
A circle. If you slice the cone straight across a circle, if you slice it diagonal, you get an ellipse. If you slice it parallel to the side, it'll actually be a parabola. And if you go straight up and down with another one on top, you get a hyperbola, which hyperbolas were the back-to-back curves.
Oh, yeah.
Yeah. Kind of been a while. It actually is not a parabola. Because if you recall hyperbolas, hyperbolas had those asymptotes in them. They have boundaries as to how wide they get. A parabola gets wider and wider and wider forever. A hyperbola's curves stay within those boundaries, so it really is not a parabola.
But the boundaries get wider.
The boundaries do, but you can't extend past those boundaries. If you really look at them, hyperbolas tend to be kind of more of a square corner. It's more of a sharp narrow as it comes around, as not as rounded out as a parabola.
What problems are we doing?
Well, I was first of all going to ask you about number 25. Do you remember how you can tell them apart?
No.
There were rules about how you tell them apart. Parabolas. They were easy because they only had one squared term, yes. Either x is squared or y is squared, but they aren't both squared. One squared variable to be correct. Okay. And hyperbolas were easy because the squared terms were what?
There's 2 of them.
There's 2 of them. All the others have 2 of them.
You can put this on a note card, right?
You're good. The squared terms, the signs are different. You'll have one of them, the other one will be minus. You'll have one of them positive, one of them negative. If it's a hyperbola, they're subtracted.
It's on the opposite side of the equal sign then.
Hey, well,
Yeah, this assumes they're all on the same side of the equal sign, yeah. Okay, that's with parabolas that we're getting there. Okay, parabolas, hyperbolas. Circles and ellipses are the 2 that are tricky because they're almost identical. Everything is all about the squared terms. The other terms, the only thing effect the other terms are having is shifting it someplace. So circles and ellipses, they both have squares, and they both are the same sign. They're both positive or they're both negative. But, what'd you say?
1 equals 1 and the other one equals some squared number or something.
The difference is the coefficients on the x squareds and the y squareds.
Oh,
circles don't have coefficients on, do they?
Circles, well, in standard form they don't, but when you're starting out they may. They have to have the same number on them.
Yeah.
Ellipses will have different numbers on x and y. The coefficients will be different.
So they have the same on both of them actually. Like they have x squared and y
Can we write this on our card?
You can write this on your little card. This I did not allow you to have on your big cards. You had to know how to do this. So if you're gonna use this, you have to put it on your little card.
So on 25, what we fill out our little card and then before they put
give them the in, that don't use them.
That's fine, yeah. You can start without your little card and then decide in the middle of the test if you want to get it or not. That's fine. Okay, 25, so looking at 25A. They're squared. They're both positive. One has a 15 on the bottom, one has a 12 on the bottom. So what's it making? Both squares, both positive. It's an ellipse, yeah. The 15 and the 12 different coefficients.
Oh, the coefficients are on the bottom.
Coefficients can be bought, okay, that's like 1/15 and 1/12. So those are, bottom numbers can still be like coefficients. Okay, so what about B? Check the squared terms. Parabola, there's only one. Okay, C.
Circle.
So we got 5x squared and 5y squared. Both same sign, both 5. So yep, that's a circle. And then last but not least, what's D? How is it a hyperbola? They're both positive.
Other positive on the other.
Yeah, they're on their opposite sides. You would have to bring the 9y squared over. They have to be on the same side before you decide. So if you brought 9y squared over, it would be minus, so they would be opposite signs, which makes it a hyperbola. Okay. So then, I asked you pretty much the basics here. Parabolas. And I actually did, you'll notice on your card, you have, I had the formula, I think most of you had my tax formulas you just stuck on your card. Yeah. Notice you have 2 columns on that parabola list. What's the difference in those 2 columns?
One's H, one's K.
Higher than that, what's the difference in the equation?
One solving for X, one solving for
Yeah,
Y.
one is Y equals, one is X equals. Okay, Y equals parabolas are the normal ones that we worked with a whole bunch back in November. Y equals parabolas are the ones that go either up or they go down. If it's X equals parabolas, then they're sideways parabolas. So that's your first thing when you look at a parabola problem is to go, is it Y equals or X equals? Because that determines which column of information you're going to follow. So, in this case, I did an X equals here. I'm not necessarily going to run this whole gamut of stuff, but if we talk about 26 a second, I'm primarily concerned about 2 places. When it's X equals, you have to be tricky about deciding where the vertex is, because I got the variables backwards. Because actually, here, let me run a normal one by you. A normal Y equals one, you all would tell me, is going to shift where?
Right 4, up 7.
Yes, this one's going to go right 4, up 7. That's normal. Okay. That one's backwards.
It's gonna go left,
Up
2,
2.
down 3.
Yeah, the Y minus 2, that's Y, that's your up and down. So yes, that's going to go up 2, right 3. It's backwards. So your vertex is going to be at 3, 2. You went right 3, up 2. So that you have to be careful of, that you notice that it's backwards if it's X equals. From there, once you find the vertex, if you read the rest of those formulas, it pretty much keys off the vertex. It tells you when you want the line of symmetry. If you're reading in that column for the X equals, it tells you the line of symmetry is it a line, an X equals? It's Y equals whatever the Y coordinate of your vertex is. Y equals 2. That's all you got to do. Direction, is this one going to go up, down, left, or right?
Right.
We already said it's sideways, and it's a positive 1/8, so it's going right. If it's a negative 1/8, it's going left. But this baby's going to go right. And then the focus was the one thing you had to calculate, and you need to read the formula off your card for that. So
H plus 1 over 4A.
you add 1 over 4A to one coordinate of your vertex, and it depends on your problem as to which one you do. Oh, thank you. Okay, so I would go, what did you say, it was H plus 1 over 4A?
H plus 1 over 4A.
Okay, so what's A? 1/8, yes. And then K is the 2 we had there. Okay, what's 4 times an 8?
Oh my god, it hurts.
4 cancels into 8, and you're left with a half. so I'll get it in a second here. 1 divided by half is 2. So that's really just 3 plus 2, or in other words, your coordinates of your focus is 5, 2. Because you just flip that fraction over. Okay, let's stop it.